So in today's lesson, we're talking about how we convert fractions to decimals. So when we want to change from a fraction to a decimal, so an example of that could be if we had 4 over 5 and we want to turn that into a decimal, right? That's what we're talking about. So it's useful to change the denominator. So when we talk about a fraction, which of those numbers is the denominator? The 5. The bottom number is always the denominator, okay? So if we can, and we can't always do this, it's useful if we change it to a power of 10. Now, powers of 10, here they are. 10, 100, 1,000. If you can turn 4 to 5 into a fraction that's out of 10, so 4 out of 5 is how much out of 10? 8. Very good. How did you do that?
Oh, I know it now. Explain.
Okay, how did you do it?
Times 2, bottom and top.
Beautiful. I love it. You multiply both the top and bottom by the same number. So you ask yourself this question: 5 times what is 10? 2. So you multiply the top by 2 and you get 8 out of 10. Now once you change a fraction
That's really cool.
to a fraction out of 10, then to turn it to a decimal, it would just be 0.8. It's just 0.8. So that's why if we can get the bottom number to be a power of 10, it works out really nicely and easily, okay? Really nicely and easily. So let's try that for a few questions here, okay? So here we go. Convert each of the following fractions to decimals. So we'll start off with 2 out of 5. So that would be what out of 10? 4 out of 10. Awesome. And what do you think that might be as a decimal? Yes?
0.4.
Beautiful. 0.4. First one. Now here's the next one. 3 out of 4. Now, we cannot make this out of 10 because 4 does not go into 10. But we could make it out of what?
2 or 8.
Sure we can, but we want this to be like 10, 100, or 1,000. If 10 won't work, let's think about maybe
12.
100. No, we want it to be like 10, 100, or 1,000. So it's easy to turn it into a decimal. So now we ask this question: how many 4s are in 100? So it's 25. So 4 times 25 is 100. What's 3 times 25? 75. So 3 out of 4 as a decimal would be what? Giddy up. 0.75. Let's go on to the third one. 73 over 200. Now, that's not going to go to 10, the bottom. Bottom's not going to go to 100. So we're going to have to go up to 1,000. So how many 200s go into 1,000? 5. So now we have to multiply 73 times 5. You don't need a calculator for that, but I guess it's okay. 365. So we got 365 over 1,000. So as a decimal, it would be what? Great. 0.365. So in order for this method to work, the denominator, the bottom number, has to be a factor of either 10, 100, or 1,000, which means it has to divide into 10, 100, or 1,000. We will not always see that. For example, what if we want to convert 2/3, 2 over 3, to actually there's a typo there, decimal. So what if we want to turn 2 over 3 to a decimal? If we want to turn 2 over 3 to a decimal, you can't do it this way because 3 does not go into 10. It does not go into 100 or it does not go into 1,000. So we need a new strategy. Long division is going to be what we need to do. So for 2 divided by 3, you'll put the 2 inside the house, you'll put the 3 outside. Of course, you'll ask yourself how many 3s go into 2, and the answer will be 0. And we'll put decimal there, decimal there. We'll add a 0 here and ask how many 3s go into 20.
Six.
6 times 3 is 18. If we subtract 18 from 20, we get 2. Make another 0. Carry it down. How many 3s go into 20? 6. 6 times 3 is 18. 20 minus 18 is 2.
Oh, so that should be a repeating 0.
Ah, there you go. It's going to be a repeating number. It's going to be 0.666666666, which we can express by just putting a bar over top. So 2 over 3 as a fraction would be 0.6 repeated, which we can also say as 0.6666 ... whichever you prefer. Like either of those is fine. The bar over top tells you the 6 repeats, or you can just write the first few digits and put ... to say the number keeps on going. But that's what 2 over 3 would be as a decimal. All right, now we're going to look at these ones. Convert each of the following fractions to decimals: 1 out of 6 and 3 out of 7. So we'll do the same thing. We'll do long division. So how many 6s go into 1? So of course the answer is 0. We'll put decimals on top and bottom. We'll add a 0. How many 6s go into, that's right. How many, so 1 6 is 6. 10 minus 6 is 4. We'll add a 0 and we'll bring it down. Now we have 40. How many 6s go into 40? 6. 6 times 6 is 36. 36 taken away from 40 gives us 4. And now we're going to add a 0. We'll bring it down. We have 40 again. How many 6s go into 40? 6. Yeah, so we see it does repeat. So it's 0 decimal 1. The repeating part is not the 1 6. It's the 6. So you could just put the bar over the 6s. So it's 0 decimal 166666666. The 1 doesn't repeat. Just the 6 does. So put the bar over the 6 is, okay? So that's what 1 over 6 is as a decimal. Now, we will skip this one right here. And the reason why we're going to skip it is because it's a long number. And I don't want to do that much long division. I want to try and get through this lesson in a timely fashion. So then that way, right after break, you can come back and just get right into the work, okay? So, long division is one strategy we can use. If the numbers are too big or too hard to work with, we can use a calculator. So now, we're going to look at some of the denominators, these ones in particular, and what they are. So we did 2 out of 3. 2 out of 3 as a decimal is what? 0.6 repeated. We did that one, right. 1 out of 3 is 0.3 repeated. 1 out of 3 is 0.3 repeated. Now we'll do the 6s. We just did 1 out of 6. 1 out of 6 is
repeated.
Very good. 0.16 repeated. The 6 is what repeats. 2 out of 6. Now, 2 out of 6, if you simplify it, is the same thing as 1 out of 3. So it's 0.3 repeated. Because it's the same as 1 over 3. 1/3 is the same as 2/6. Because you just multiply the numerator denominator both by 2. 3 out of 6 is actually the same as a half. So that's actually 0.5. No repetition, just like 50% or half of something. 4 out of 6 is the same as what? What's that?
0.6.
Yeah,
0 out of 3.
perfect. Same as 2 out of 3, so 0.6 repeated. Great. And then we have 5 out of 6. Now, 5 out of 6 is a little trickier. It's 0.83, and the 3 repeats. So it's 0.833333333. Okay? Now, we'll do the 7s last because they're a little wonky. 9s. 1 out of 9 is 0.1 repeated. So 0.11111111. 2 out of 9 is 0.2 repeated.
Is it going to be like 0?
What do you think 3 out of 9 will be?
0.3?
0.3 repeated.
Oh, okay.
And it just keeps going like that. 0.4 repeated. 0.5 repeated. 0.6 repeated. 0.7 repeated. And 0.8 repeated. So 1 out of 7 is 0.142857
What?
repeated.
How do you just know that? Just repeats those.
2 out of 7.
How you just explained it.
Now 2 out of 7 is 0.285714. Now I want you to look at something kind of cool here.
So it's all
You're starting at 2.8. 2.85714. The numbers go in the same order, they just start at the 2. The next one, you have to use a little bit of logic here. 3/7 is a little bit less than a half. So what do you think the first digit's going to be? What's that? 4. It's 0.428571. Because if it's just a little bit less than half, it's 0 that starts with the 4. Now, 4 out of 7 is just a little bit more than half. Which of those numbers would be just a little bit more than a half?
0.7.
I love the guess. It's actually 5 though. It's 0.571428 repeated. And again, you can use this sheet of paper to do your work. When it comes time to study for your test, you can write some of these on your study sheet. For 5 out of 7, someone said 7 before, that's where we're starting now. So it's 0.714285. 714285.
So we can start with 8.
Bingo, you got the right idea. 0.85714. Oops, I'm missing one there. 85714. Oh, 2 at the end. There you go. So there's your 6-digit repeated number. So this is why sevens are just a little bit trickier, because 7's a larger number and it's prime. 9's not a prime number, it's a composite number. Like I said, 11 and 13, like if you looked at denominators of 11 and 13, those would be really kind of crazy like this too, but we're not going to do much with those. So anyway, that's what because these we cannot turn into fractions with denominators of 10, 100, or 1,000. So we're looking at some smaller fractions that we're not able to do that with, okay? Now, we have a couple minutes before break. Let's go ahead and finish this off, okay? So, or get really close. Decimals that stop are said to terminate. If decimals don't stop, they are said to be repeating decimals. So for example, if you have 1/3 is 0.3 repeated, that's a repeating decimal. But if you have 1/4, which is 0.25, that terminates because there's no digits after the 5. So for 1/2, for right now, we can use, what do you think 1/2 is as a decimal? 0.5, so does that terminate or repeat? It terminates, so I'm just gonna put a T. Now, 5 out of 8. Do you think you can make that bottom number 10, 100, or 1,000?
No.
You can't make it 10. You can't make it 100. But you can make it 1,000. And you make it 1,000 by multiplying top and bottom by 125. So, and actually 0.5 over 8,
Oh, like times 20.
because we can multiply 5 and 8 by the same number to get to 1,000, then 5 over 8 would actually be 0.625, and that terminates. Next question, we've got 4 out of 11. And actually 11's not bad for the for what it is, but you cannot make the bottom 10, 100, or 1,000. Use your calculators. Tell me what 4 out of 11 is. You gotta get a repeating number.
Can I grab mine?
Where are the calcs? How do I?
0.36 repeated.
0.36 repeated.
Wait, how do
So
I?
because it repeats,
Oh,
it's a repeating number. Just 4 divided by 11 will give you 0.36363636. So, to change a decimal from a fraction, there's 2 ways to do it. Okay? So if you want to change a decimal and make a fraction, there's 2 ways of doing it. If it terminates, like for example, the decimal 0.14, you take the digits after the decimal, which is the 1 and the 4, and because there's 2 digits after the decimal, you put that number, 14, over 100. And the reason why it's 100 is because there's 2 digits after the decimal. 2 digits after the decimal, 2 zeros in 100, right? If there's only 1 digit after the decimal, then there's 1 0. If there's 3 digits, there's 3 zeros, okay? So 0.14 is 14 out of 100. Now, if you have a repeating decimal, such as 0.5 repeated, you still use the number 5, the digit after the decimal, but the bottom is not going to be 10. Instead, you use either 9, 99, or 999. So here's what you have to ask yourself. Is there 1 repeating number? Is there 2 repeating numbers? Or is there 3 repeating numbers? If there's 1 repeating number, you use a 9. If there's 2 repeating numbers, use 99. If there's 3, use 999. So 0.5 repeated is 5 out of 9. Okay? Finally, we're going to take 3 decimals and we're going to turn them into fractions in simplest terms. So 0.7 would be what out of what? 7 out of 10. Can we simplify that?
no.
No, because 7's a prime number and 7 does not go into 10. So there's no number that goes into 7 and 10. So that's as good as it gets. Then we have 0.21 repeated. What would that be
0.1.
as a fraction? What's that?
21 out of 99.
21 out of 99. Now, when I think of 21 out of 99, though, I say to myself, both of these numbers can be divided by 3. How many 3's go into 21? Very good. How many 3s go into 99? 33. So 0.21 repeated would be equivalent to 7 over 33. Okay? And I have just one last one for us to do, and then it's practice time. 0.36.
36 out of 100.
36 out of 100. And we can simplify that. What does it simplify to? What divides into 36 and
10 out of 100.
what's that?
10 out of 100.
I love the guess, but no.
7.
What goes into 36 and 100?
Yes.
Yes? Here's a clue. Divide them both by 4.
4.
9 over
9. 8.
25.
7.